Hi guys, welcome back to another video. In this video we are looking at dividing fractions. So hopefully by the end of this video you'll know what a reciprocal is and you'll know the steps involved in solving division of fractions. And you're going to be able to hopefully find the reciprocal of a given fraction and be able to solve the division of fractions problems. So first let's talk about, what is a reciprocal? Now the reciprocal is when we flip a fraction. So we put the denominator at the top and the numerator at the bottom. So for 3/7, if we were to find the reciprocal of that, we would get 7/3. So we're flipping it over. If we were to look at the number 5, the first thing we have to remember is that 5 is the same as 5/1. We have to have it as a fraction. Then we find the reciprocal of that by flipping it, and we get 1/5. I want you to pause this and I want you to do 1/5 and 9. So hopefully with 1/5, when you flip that, you got the number 5/1. Now you could simplify that down to 5, but because we're going to need this to solve a division problem, we would keep it as 5/1, unless it asks us to simplify it. And then for 9, you put it as 9/1, and then you flipped it, so you get 1/9. So let's start with this question. How many lots? So how many lots of 1/5 are in 2 wholes? So 2 whole numbers, how many lots of 1/5 are there? So we've got our 2 wholes here. Now if we divide each of these into 5, we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 lots of 1/5 in 2 wholes. So in 2 whole numbers. Let's look at saying it another way. So again, I'll just repeat the question of how many lots of 1/5 are in 2 wholes. And we know that the answer is 10. Can we solve this mathematically? Well, what we're actually saying when we say how many lots of 1/5 are there in 2 wholes is we're saying, well, what is 2 divided by 1/5? Now, the first thing we're going to do is change that whole number to a fraction. And we remember that we do that by putting it as 2/1. Now what we need to do is we find the reciprocal of the second fraction. Remember, it's the second fraction. So we flip the second fraction and we change the division sign to a multiplication. So if we were to flip the second, we end up with 5/1 instead of 1/5, and we've changed the division into multiplication. Now we know how to solve multiplication. The first thing you would do would be looking for cancelling, which in this case we don't have any because we've got the number 1s at the bottom. And then what we would do is multiply our numerators and then our denominators. So 2 times 5 gives us 10, and 1 times 1 gives us 1. And so of course we say this at the end as being the number 10 because we're simplifying it down. In this case we're saying how many 1s go into 10, which is 10 wholes. Now, I want you to circle the part of the expression that you will find the reciprocal of. So these are all divisions, so which one, just circling them, do you need to find the reciprocal of? So the first one is 6/7. Now pause this and do the other 3 and then come back. So hopefully you circled 8/3, 4 and 9 because we always find the reciprocal of the second fraction. So let's do some examples here. So 1/7 divided by 3/5. So again, our first step is to flip or find the reciprocal of the second fraction. So we end up with 1/7, 5/3, and we change that division sign to a multiplication. Now we would simplify it down if we could, but we can't, so we go 1 times 5 and 7 times 3, which gives us 5/21. Now let's flip the other one. It's important to note in this case because if you look at this, you might think you can simplify it first, but don't simplify until after you have flipped it. You can only ever cancel down a multiplication. Okay, so we just leave this as it is for now. Then we flip it, we flip this second one and we change it to multiplication, And now we can look at cancelling. So we've got our 2 and our 6 here, and a common factor between 2 and 6 is 2. Now 2 goes into 2 once, and there are 3 2s in 6. And then we have 9 and 12, which also share a common factor of 3. And 3 goes into 9 3 times and into 12 4 times. So what we end up with is we take 1/3 times 4/3. Now it doesn't matter that this is an improper fraction. We leave it as an improper fraction until the very end. So what we're going to do is go 1 times 4 over 3 times 3, and we end up with 4/9. And you can see that even though we had an improper fraction here, our final answer was not improper. Let's do the last one. So again, first what we need to do is convert them into improper fractions, because again, like multiplication, we can't multiply or divide improper fractions. Mixed numbers. So we've turned them into improper fractions, and then we're going to flip that second one, which is our 7/20 here, and we're converting this into a multiplication. Now look to see again if you can simplify. 8 and 7 can't be simplified, but 35 and 20 can. So what is the highest common factor of 35 and 20? Well, if the number ends in 0 or 5, 5 will always go into it. So 5 goes into 35 7 times, and it goes into 20 4 times. So if we were to rewrite this, we would get 7 times 4 over 7 times 7 over 8 times 4. So we end up with 49/32. Then what we're going to do is convert that into a mixed number by saying how many times does 32 go into 49, which is once. And if we take 32 parts out of here, how many parts are left, which is our 17. So last question is a worded question. So students in technology and design class are making costumes for the school musical. Now I might get a pen here. A total of 35 meters of fabric has been purchased. If each garment requires 1 3/4 meters of fabric, how many garments can we make? So we're going to turn this into a division sum. And what we do is we go 35, because that's what we have, divided by 1 over 3/4. Now converting this into an improper fraction, we get 35 over 1, because we need this as a fraction, divided by 7/4, because we went 1 times 4 is 4, plus 3 is 7, which makes our 7. Now we're going to flip the second one and change it to a multiplication. Now again, remember, we always look for common factors. 1 and 4 we don't worry with, because 1 is the only factor of 1. And 35 and 7, well, 7 goes into both of these. So how many times does 7 go into 35? It goes in 5 times, and it goes into 7 once. So our new sum here is 5 ones over 4 ones. Times 4 ones. So what we do is we multiply our numerators and our denominator, and we get 21s. Now what we're going to do is convert this back into we're going to simplify it. So how many times does 1 go into 20? Well, 1 goes into 20 times, and there's none remaining. So we make 20 garments out of 35 meters. Thanks guys, I hope you understood this. If you have any questions, make sure you ask. Otherwise, I'll talk to you in the next video. Thanks guys.